Hello students, welcome back to the next module of a chapter called electromagnetic induction. Now students, in this particular module again we'll be continuing with the MCQs which are based on concept of transformer, right? So let us start with the first MCQ of our module. It says a step down transformer has a turns ratio 20:1. If 8 volts are developed across 0.4 ohm secondary, then the primary current will be, and the options are option A 1 ampere, option B 2 ampere, option C 4 ampere, and last option is 0.5 ampere, right? So let us analyze this and let us write down the given data. Over here we are provided with step down transformer and turns ratio is 20:1. So therefore I can say NP upon NS, it is equal to 20/1. If 8 volts are developed across 0.4 ohm secondary, so here load resistance is 0.4 ohm, and how much voltage is getting developed? 8 volts is getting developed. So I can say voltage across secondary, that is Vs, it is equal to 8 volts, and the value of Rs, that is load resistance, it is equal to 0.4 ohms. What we are supposed to find? Here we are supposed to find primary current, that is Ip. Right? So let us start with the solution. Now again we'll be using the basic equation of transformer. What is the basic equation? It is NP upon NS, it is equal to Vp upon Vs, and it is equal to Is upon Ip. Now students, over here we are provided with the value of NP and NS, right? That is NP upon NS we are provided, right? And we are supposed to find out the value of Ip. So we can rearrange this and I can write it as NP upon NS, it is equal to Is upon Ip. Now let us see which all values are given. We are provided with the value of NP upon NS, right? What is the value? It is 20/1, right? Now, do we have value of Is? No, we don't have value of Is, but we can calculate, right? Now let us apply Ohm's law. So by Ohm's law, I can say Vs, it is equal to Is into Rs. Now I'll rearrange. So after rearranging, I can write Is, it is equal to Vs upon Rs. Now what is value of Vs? The value of Vs, see carefully, it is equal to 8 volts. Now we also know value of Rs. What is value of Rs? It is equal to, yes, it is equal to 0.4 ohms. So if I substitute these two values, what will I get? I'll get Is, it is equal to 8 upon 0.4, which comes out as 20 amperes. So we got the value of Is as well. Now we are supposed to calculate Ip. Right? So let us substitute these values. So after putting, we get 20/1, it is equal to 20 upon Ip. On cancelling, I'll get final value of Ip as 1 ampere in this situation. Right? So which option is matching? Yes, option A is the correct answer in this situation. Right? Now let us start with the second MCQ. It says the primary winding of transformer has 50 turns while its secondary is having 500 turns. If the primary is connected to an AC supply of 220 volt 50 hertz, then the output at the secondary will be, options are option A 220 volt 50 hertz, option B 2200 volts at 50 hertz, option C 2200 volts at 500 hertz, and last option is 22 volts at 5 hertz. Now students, one point that you need to remember is that whenever you are using a device called transformer, there is no change in the frequency of the voltage, right? Whatever frequency of voltage you provide at the input side, same frequency voltage you will obtain at the output side, but the values of voltage may change. Now see carefully the given question. It says the frequency of input voltage is 50 hertz. Now see options carefully. Option D, in option D we are having the frequency of voltage as 5 hertz. So I can say option D is incorrect, and in the similar sense I can say option C is also incorrect because the frequency over there is 500 hertz. Now see the first line carefully. The primary has 50 turns and the secondary has 500 turns. So I can say it is a step up transformer, and so the value of output voltage will always be greater than the input voltage, and in this case input voltage is 220 volts. So see the options carefully. So technically option B is the correct answer in this particular situation. Now let us calculate it mathematically, right? So let us write down the given data. We have NP, we have the value of NS which is equal to 500, we have the value of EP. What is the value? It is 220 volts at 50 hertz, and we are supposed to calculate value of ES. Now again we'll be using equation of transformer, right? What is the basic equation? It is ES upon EP, it is equal to NS upon NP, right? Now we have to find out ES. We know value of EP, it is 220 volts. We also know value of NS, it is equal to 500, right? We also know value of NP, it is equal to 50, right? So let us substitute. So we'll get ES upon 220, it is equal to 500 upon 50. Now I can cancel out 50 and 500 as 1 times, and 1 0 0 will get cancelled, right? So it will become 50 upon 5. So let us transfer 220 on right hand side. So what we'll get, ES it is equal to 50 multiplied by 220 upon 5, and on calculating you'll get the final answer as 2200 volts. So which option? Option B is the correct answer. Now let us move further. Over here we are provided with transformer which reduces the main supply from 220 volt to 20 volts, and the currents in the primary and secondary coil are 2 ampere and 15 ampere. We are supposed to calculate efficiency of transformer, and the options are 65%, 75%, 80% and 90%. So let us write down the given data. Here we are provided with input and output voltage. Therefore, I can say value of VP and VS are given. It is 220 and 22 volts. We are also provided with the value of IP and IS, that is equal to 2 ampere and 15 ampere respectively. Now let us calculate efficiency. So we are supposed to find neta, right? So let us start with the solution. So I can say efficiency neta, it is equal to VS into IS upon VP into IP. Right, that is nothing but output power upon input power. So let us substitute the values. We know value of VS. What is value of VS? It is 22. Right. We know value of IS. It is equal to 15 amperes. Right. We also know value of VP. It is equal to 220 volts. Right. And we also know value of IP. It is nothing but equal to 2 amperes in this particular situation. Right. So all values are known. Let us substitute these values. So what will I get? Neta, it is equal to 22 into 15 upon 220 into 2. And if you calculate this, you'll get 3 upon 4, which is nothing but equal to 0.75, which is equal to 75%. So which option is correct? Option B is the correct answer. So students, in this particular module, we have covered MCQs which are based on transformer. That's it for this particular module. See you in the next module.